Hello and welcome to this session on the 5 considerations for integrating with cloud applications. My name is Rajesh Raheja. I'm the Senior Director of Product Management in the Oracle Fusion Middleware Business Integration Group. In this session, I would like to bring forth the challenges that IT faces with cloud integrations and then discuss some specific considerations for cloud integrations that have been implemented by many of our customers. Let's look at why planning for cloud integration projects is important. A lot of the customers and CIOs we meet have expressed their frustrations and challenges when trying to integrate SaaS applications into their IT infrastructure. Today, most companies are still overwhelmingly on-premise. Information in SaaS applications will need to integrate with these systems to avoid data silos and create value. For example, implementing an end-to-end business process such as order to cash between a Salesforce.com or an Oracle Fusion SaaS CRM system and an on-premise system such as the Oracle eBusiness Suite. So what happens is typically that one department within a company such as sales attempts to host their CRM with a SaaS application provider and builds point-to-point integrations to their on-premise system. Next, more divisions such as marketing join in using other SaaS vendors and applications with their own point-to-point integrations, and soon the company finds itself with an accidental cloud integration architecture that is not aligned with the IT strategic vision, is difficult to upgrade when endpoints change, and there is no centralized management, monitoring, security, accountability, and compliance. Many enterprises who attempt cloud integrations end up in this state. Why is that? If SaaS APIs are simple web services, then what's the issue? Why is integration still hard? The issue is that we suffer from a dichotomy of standards. Cloud integration technologies are based on web services standards such as HTTP, SOAP, REST, which is definitely a good start and makes them easier to code for. However, there are no functional standards for SaaS application semantics that make them interoperable with each other. This leads to every SaaS vendor having its own flavor of standards for object semantics or customizations, business rules, security, for example, using session headers, RBAC, and so on, quality of service, such as using guaranteed message delivery and once and only once message delivery, different styles of API patterns to do cross-reference mapping, to do the different styles of queries, such as using a Java style or a SQL style query, the approach that ISVs would use, for example, using loosely typed or a strongly typed WSDL, and also the approach to data integrations, for example, the different types of CSV file formats. This is the reason integrations are hard, and it's not due to a lack of any kind of fancy tools to build REST clients. This problem has existed since the beginning of on-premise apps, and it's only becoming more complex with SaaS, with increased adoption by new programming SDK and mobile clients. Most SaaS vendors realize this and have API documentation that run in the hundreds of pages, or sometimes rely on integration ISV partners or proprietary platforms, which further increases the IT challenges. And that's not all. This was just a problem integrating one cloud app with another. Most large companies have multiple instances of on-premise applications and multiple SaaS applications with potentially different release and patch levels. Each of these application releases may have their own data model changes, functionality, and customization differences that further complicates the integrations and increases costs. Again, this is why integrations are complex, even SaaS integrations. It's no wonder as cloud adoption increases, we are seeing growing evidence of challenges that companies are facing, making them see through the hype and false perception that cloud integrations are somehow special or simple or just a bunch of REST APIs. Analysts do agree that cloud integrations can get messy, and they are more than just web services. So what do we do about this complexity? The key is that IT needs to plan for cloud integrations as any other app integration project. They need to pragmatically address the architecture issues, such as functional configuration differences, organization and business unit setup, chart of accounts, business process differences. What process am I implementing? What apps are going to satisfy my functional and non-functional requirements? How do I handle batch versus transactional needs? For example, CRM may take orders individually, but the ERP processes them in batch. Data model differences, such as cardinality differences, missing attributes, or attributes that are on different objects requiring enrichment. Make no mistake, even seemingly simple structural differences in attribution can increase integration complexity. One example I can recall was from a pre-built integration project we were working on to sync product information between a CRM system and a billing system. The CRM system had a flexible data model that could price and discount a product based on an attribute. For example, an iPhone with a white color or a black color may have different price information. The billing system was not that flexible and could only bill based on a product SKU. This meant denormalizing the flexible CRM model to match the billing system requirements and create a billing product SKU for every combination of the CRM product and the attribute on which the price could be based on. So for example, now having a white iPhone and a black iPhone instead of just a product called iPhone with the attribute of color. So again, this would now require complex cross-referencing of information between the CRM product IDs to the billing system product IDs for any future upgrades. Another example would be cardinality differences in order structures between applications, such as one application having a 3-level order, header, line, and distribution versus another application having a 2-level order, header, and lines only. Or one application might support multiple address types, such as bill to or ship to, but another application might have only one address field. Which one would you populate? So these are some of the decisions that have to be made when looking at data model differences. On the customization extension front, say you wanted to add a new attribute to capture a customer's geographic location in your CRM and ERP systems so as to correlate the order revenue by geography. You, of course, need to extend both the CRM and the ERP object attributes, but also the integration ETL scripts and the XSLT mappings need to be modified to pass the new attribute between the two systems. Note that each application may also have different mechanisms for customizations themselves. For example, CRM systems may suffice with adding descriptive attributes, but ERP systems may need more context-sensitive optional attributes, such as if anybody has used the Oracle e-business suite system, you may be aware of key flex fields and descriptive flex fields. Finally, you also need to take care of non-functional issues such as performance, identity management, as well as design time issues around programming models, SOA governance, data governance, and so on. So all these have to be accounted for in any integration, and SaaS integrations are really no different. These integration architecture issues are not new, and neither are the solutions. Service-oriented architecture is an ideal platform to address cloud integration, since it's a classic application integration problem where some endpoints happen to be outside the enterprise firewall. SOA integration concepts, technologies, methodologies, design patterns are more relevant in the world of cloud integration due to special considerations of spanning the enterprise. When speaking of SOA, there is a clear set of functionalities you need. The Oracle SOA Suite provides a foundation to simplify connectivity to cloud and on-premise applications with a complete unified infrastructure. SaaS application connectivity is available both at the application level as well as down to the discrete service level, for example, to Salesforce.com. Oracle Fusion Middleware also provides tools for near real-time as well as batch integrations. Service and data model virtualization provides decoupling of service consumers and providers that result in greater flexibility, and orchestration allows you to create new value in the organization by implementing business processes. And these are all available using the Oracle Service Bus and the Oracle BPEL Process Manager set of technologies. Visibility into technical operations is available using the Enterprise Manager SOA console and business transaction monitoring. You can also monitor business metrics and KPIs with Oracle BAM. Oracle Enterprise Repository, the SOA governance solution, allows you visibility and control over all the services and metadata in your infrastructure. You can secure the services using the Oracle Web Services Manager and Oracle Enterprise Gateway. And scalability can be ensured using in-memory results caching and visibility into technical operations. Many of our competitors, open source, cloud, or otherwise, may claim some or all of these features individually. What's unique about Oracle SOA Suite is the extent to which all this functionality is unified within a single design and management platform. This allows you with a single integration infrastructure for your A2A, B2B, cloud, data, social, and mobile integration projects. As I mentioned earlier, the cloud does have additional considerations due to its inherent nature of being outside the enterprise boundaries and control. Let's talk about the most basic of considerations. How do I connect my SaaS applications with the on-premise systems? Can I reuse my existing SOA platform, or do I need yet another integration platform outside the enterprise? When talking about connectivity considerations, you may be thinking of SaaS APIs as simply a web service call, but it usually ends up being more involved than that. There are various differences in SaaS application API styles, protocols that are used, and the restrictions that are imposed to successfully invoke the API. Some APIs, such as Oracle Right Now and Salesforce.com, depend on a polymorphic pattern that offers flexibility but requires a bit more work in consuming the services. Instead of each service operation being unique, there are a fixed set of operations that take in any object. For example, in Oracle Right Now, instead of a create contact operation, there is a generic create operation that works on objects such as contact or incident, that is, objects inherited from a base Rn object type. In addition to polymorphism, different SaaS vendors also have varying needs for things like session headers, authentication, dynamic endpoint URL generation, API optimizations, and limitations on the number of records. Oracle SOA Suite can easily connect with the different kinds of SaaS web service APIs. You can directly invoke the web services from the SOA Suite components by importing the WSDLs as an external reference and then invoking the operations. Polymorphic operations can be easily handled by selecting the subtype using substitution elements in the XSLT mapper and other tools in the Oracle SOA Suite. Session headers can be set easily in the BPEL process manager using assign statements. Security can be handled without any coding using the Oracle Web Services Manager. For some SaaS vendors, such as Salesforce.com, there are adapters available that can perform this special handling, such as connection semantics of using login methods and dynamic endpoint URLs, or setting these session headers, understanding the polymorphic operations, etc. This eliminates the need for having any detailed Salesforce.com WSDL or their Apex language API knowledge. You need to be careful, though, if thinking that this solves all the problems. First, the adapters, especially ones not created by Oracle, will require its own learning curve, so you may be trading one problem for another. Secondly, if any third-party adapter is not tightly integrated with Fusion middleware, you end up with the same problems of lack of unified monitoring and management. So adapters may be a worthwhile investment if you have a lot of different API calls with one SaaS vendor that require this kind of special handling. On the other hand, if you have a few API calls to many SaaS vendors, you may still be better off implementing them once natively using the Oracle SOA Suite and then reusing those services elsewhere. Just to give you a data point, most of our customers who use Oracle SOA Suite to connect to Salesforce.com use the native Oracle SOA Suite features to do so without any adapters. Next, let's talk about how to minimize impact of change in the cloud APIs or in our own business processes. We visited the accidental cloud integration architecture right at the beginning, so how do we avoid this? The solution is to create a service virtualization layer, which can be implemented using the Oracle Service Bus. This provides strategic value in location transparency, technology abstraction such as switching between protocols, entity normalization such as transforming shape between the source and the target, as well as service reuse. It provides a point of control and management for integrations, allowing you to control the quality of service as well as the API facade, for example, using a canonical object model to be exposed to your API consumers. A service virtualization and mediation layer can decouple service consumers and providers, providing for location transparency. It can assist with technology abstraction, such as switching between transport mechanisms, JMS to REST or SOAP, sync to an async operation. It provides endpoint management with service pooling and results caching for scalability and reliability, and also provides message routing so that API invocations can be routed to different versions of a service implementation. All this enables flexibility in your hybrid cloud environment. Now that we have connected, normalized, and decoupled the API provider and consumer, we can create new coarse-grained services. There are two use cases where you may need to map SaaS APIs to your business process. The first is to aggregate fine-grained chatty SaaS APIs so that they can be effectively reused consistently and productively by multiple consumers in your enterprise. The second is to extend enterprise applications by externalizing the business logic and rules. For example, in a workforce lifecycle management, when hiring a new employee, you need to order a laptop and a badge. But if the new employee is a vice president or above, you may want to order a credit card and also, if approved, an iPad. The chatty service aggregation can be achieved using technical service orchestration in the Oracle BPEL Process Manager. Extending enterprise applications can be achieved using the Oracle Business Process Management for process logic, the Human Workflow Task Manager for approvals, and the Oracle Business Rules Engine for externalizing who is eligible for a credit card or how many levels of approvals are required for an iPad. Application integration flexibility is not specific to cloud integration, so it makes sense to reuse existing SOA best practices and methodologies. For example, when looking at loose coupling, you can take the technology abstraction a step further with data model abstraction using canonical models. Usage of a canonical format is an integration best practice, especially in integrations that involve connectivity with multiple source and/or destination applications. Each participating application then has to only transform its message to the canonical, which isolates the impact of change either due to upgrades or patches to that one transformation. But are canonicals really appropriate for all scenarios? With canonicals, an end-to-end message flow now has to go through two transformations, one from the source to the common format, and then another from the common format to the target. So for a request reply message, you now have 4 transformations that are being executed, which does introduce additional overhead. So when should you think about using canonicals? The bottom line is that change is inevitable, and adopting a canonical pattern can help minimize that impact. In addition, the overhead due to canonicals of an integration with 3 or more participating applications become no worse than that of a direct integration between 2 applications. However, if you have integrations that require very low latency, for example, less than 5 seconds end-to-end message transfer, or if it is a transformation-intensive process, that is more than 60% of your flow is just spent on the transformation of objects, and if you demand high throughput, or if the 2 applications that you're trying to integrate have very similar underlying schemas, then a direct integration in these kinds of scenarios may be a pragmatic choice. Similar choices also have to be made when thinking about using an ETL-style bulk data integration instead of a near real-time service-oriented integration. The Oracle Foundation Pack provides best practice methodologies and design patterns to guide you through some of the pragmatic choices that I just discussed. If you do decide to go with a canonical style pattern, you also don't need to start from scratch, as the Foundation Pack offers pre-built common object and service definitions to jumpstart your integration projects and reduce cost. For data integration needs, Oracle Golden Gate provides real-time replication capabilities, log-based change data capture, and routing and delivery between heterogeneous systems. Oracle Data Integrator is useful for batch-based incremental data transfers using ETL-style patterns across the on-premise applications and the cloud. The next consideration is to get visibility into the available services, as well as technical operations and business metrics in an extremely distributed architecture. The challenge here is that you need visibility into your service deployment. You need to understand what services are available, how are they documented and delivered, can developers discover the service details and the taxonomies, the endpoint URLs, and what the security requirements are to invoke these services? Do you understand the impact of any change? For example, what applications are affected? What is the ROI on your services? Who is using them? And what kind of interfaces are they using? The Oracle Enterprise Repository, or OER, is a catalog of integration assets and their metadata that provides you with the visibility and control over the service lifecycle. It allows you to discover available services for consumption, report on the impact analysis for change management, and highlights performance and SLA compliance metrics by integrating with Oracle Enterprise Manager. It also enforces flexible design time policies at each stage of the service lifecycle. Oracle Enterprise Repository for Fusion Applications, which is a cloud-hosted instance from Oracle, gives you some examples of how OER can be utilized for a wide range of application integration content. You can register for an Oracle account and browse through the OER for Fusion applications at fusionappsoer.oracle.com. Now that we looked at design time visibility using Oracle Enterprise Repository, the runtime visibility into technical operations is provided by the Oracle Enterprise Manager with the SOA management pack. It provides a unified management environment that can monitor the entire lifecycle of a transaction across different components, such as the application server, the web services, composites, and the business rules. Visibility into business metrics and KPIs is provided by the Oracle Business Activity Monitoring, or BAM, and industry-specific dashboards. Next, let's look at managing security in the cloud. Anytime you open up your enterprise to the cloud, you need to have protection against various denial of service attacks, XML bombs, invalid messages, and so on. You also need the security policies to be agile enough to manage centrally so that should the need arise, you can quickly change the policies in case of a security breach. To secure against external threats and attacks, you need to implement perimeter security at the DMZ, something similar to a firewall. This is provided by Oracle Enterprise Gateway that can help shield against the different types of attacks. For example, it can filter invalid web service requests. It can perform schema validation to ensure that the messages can be parsed. It can prevent denial of service attacks through XML bombs, which are small messages that are designed to overpower your XML parsers and bring down the app server by exploding the message size drastically. It can perform message throttling that can prevent the maximum number of concurrent web service requests from being exceeded. This is usually a SLA that is set between the client and the web service provider. When you expose any public web service, you need to have multiple levels of security. The demilitarized zone, or DMZ, is the first line of defense where, as we just saw, you typically need a firewall such as the Oracle Enterprise Gateway. The green zone is behind the DMZ, and the message may be directly forwarded to the web service or may be redirected via some service virtualization layer such as the Oracle Service Bus. In both cases, a runtime security policy engine secures access to the web service to ensure that no man-in-the-middle type of attacks can occur. The Oracle Web Services Manager provides this centralized security policy management as well as the distributed runtime agents that execute at the various tiers. This separation of the security layer from the underlying business functionality implementation provides you with the agility in reacting to changes in security, a critical aspect in the cloud. For example, a simple policy change can mandate the use of SSL or WS security message encryption should the need arise. Finally, let's look at scalability. One of the challenges in the cloud is how to maintain performance and reliability despite the quality of service variance in the cloud provider APIs. A common scenario is unexpected surges in transaction throughput, some of which may be predictable trends, for example, sales during holiday periods, but in other cases there may be outages with the cloud provider that you may need to deal with. The service virtualization layer introduced earlier for flexibility allows us to handle these demand surges. It can offer service pooling to efficiently handle many requests, important when performing transformations or orchestration logic that can be cached and distributed. It can perform request throttling, which can be an important capability to control the load on the back-end systems and protect the IT systems from getting overwhelmed. It can also perform service results caching, which can act as a way to manage load, not just the availability aspect of it. The way service results caching works is by eliminating the latency time associated with repetitively accessing static backend data and caching it for future access. It can drastically improve your performance by reducing the network request to the application. Especially in the case of the cloud, it reduces high latency round trips inherent in internet-based communication across the multiple firewalls. In some cases, it can also ensure high availability of the services above and beyond what the service providers can deliver. For example, looking up static information such as product catalogs or information that does not change very often, such as weather forecasts. And it is as simple as activating with a simple checkbox. When we talk about scalability, tools definitely help. For example, the Oracle Service Bus with Coherence in-memory caching, and Oracle Enterprise Manager with visibility into technical operations. But more importantly, scalability and especially reliability is also about the architecture and design of your cloud integration. As we had seen with downtimes caused by the Amazon Web Service outages some time back, many web applications were not built to take advantage of the Amazon Web Service availability zones and regions. Your cloud integration needs to be architected for scalability and reliability. It needs to be designed to expect high latency and random outages. Some things to consider would be when to use batch-style integrations that does not rely on near real-time services being available. Another consideration would be use of asynchronous messaging, especially if you need very high throughput or have long-running transactions. You could use a messaging service for guaranteed message delivery. Those were some of the cloud integration considerations. Now let's take a look at how some of Oracle SOA Suite customers have implemented their cloud integrations. Oracle SOA Suite is already being used for cloud integrations by many customers. For example, integrating with Salesforce.com. Electronic Arts wanted a platform that could scale with their new business models around digital delivery and gaming as a service. Their digital order-to-cash business process, which is a mission-critical process that orchestrates orders between the on-premise systems and cloud systems, processes more than 2 million messages daily and uses the Oracle SOA Suite along with the AIA for the implementation. BMC runs 70% of their business on the cloud, including sales, marketing, employee office management, and so on, and has incorporated a new SaaS application every quarter since 2009 and use Oracle SOA Suite and the AIA canonical style messages for their service virtualization. Chick-fil-A is the second largest quick service restaurant whose IT had been challenged to scale with the business by employing a strategy to leverage partners to deliver solutions where possible. To do this, they fundamentally reinvented their architecture to be middle out, which is an architecture that is focused on the integrations and not on the application. Their integration hub is a direct enabler of this IT strategy, including SaaS application integrations. It is powered largely by Oracle SOA Suite, AIA for canonical models, Oracle Enterprise Gateway for security, and the Oracle Enterprise Repository for governance. Cisco has automated their order orchestration process using an event-driven, loosely coupled integration architecture that is based on the Oracle SOA Suite. It integrates with their on-premise systems, with their ERP systems such as the Oracle E-Business Suite, and cloud applications such as Salesforce.com. Eaton is a diversified power management company and needed a flexible, scalable, and standards-based integration strategy to handle its large acquisitions and manage more than 30 on-premise and cloud ERP systems. They chose Oracle SOA Suite with AIA as their integration platform and also are planning to use the Oracle Enterprise Repository as a governance platform to ensure that the integration projects all leverage the proper resources, tools, and technologies. UNS Energy leverages Oracle SOA Suite, Oracle Service Bus, and the Oracle Web Services Manager to implement their web services so that they can deliver the data securely to their partners and vendors. So in a way, they have implemented their own cloud application using the Oracle SOA Suite. To summarize, the key takeaways are: treat your cloud integration projects as any other application integration initiatives for maximum success. Use a strategic integration platform to simplify your integrations across all the channels and address all the cloud considerations. And finally, Oracle SOA Suite has been proven for cloud integrations by some of our most demanding customers, as we just saw some of these examples. That's it. I hope this session has been useful, and I look forward to your feedback on our social media channels. Thank you for your time.